Hey guys, welcome back from spring break. I hope you had a good break, being able to just have a little bit of relaxation from school. Hopefully you're able to come back and who knows what's going to happen in the next few weeks, but we're going to continue on this week looking at chapter 11. I know we talked about this a while ago, but if you haven't gotten a calculator or have access to a calculator, you can use your computer for that calculator. There are a lot of apps that you can use on phones too, so you don't have to buy the physical one that we talked about, but have access to calculators that have the sine, cosine, and tangent functions. We'll be needing those next week, so if you don't have those already, make sure you try to get access to one of those, again, on your computer, on your phone. Even the Chromebooks have it, so if you have that, you should be good. If you have sine, cosine, and tangent, that's sin, cos, and tan buttons. So just be ready for those. Okay, today we're going to be talking about, though, ratios and rates. And I split this lesson up into two because the first lesson will deal strictly with these two ideas. And then we're going to have some what we call unit conversions tomorrow. So we'll finish up that lesson tomorrow. And that takes a little bit longer to explain. Okay. We have dealt with ratios. I think you've dealt with ratios every year since probably fourth grade. And so ratios are really important because ratios are simply a comparison of two numbers. It could be two or more numbers, but usually you're comparing two things like boys to girls. How many days of physical classroom did you have in eighth grade to online classroom? Things like that. You're just comparing two numbers. There are three forms I want you to know. What we call word form. Word form. That's using the word to. So when you see the word to, that's dealing with a word form, which we will deal with some problems in that format. We also have what we call ratio form, which is very typical of what you see in math. So ratio form, you'll have those two, that colon. So there you have that, like the time symbol. And then you also have fraction form, which is the most common form of a ratio. By the way, a ratio, we said comparison of two numbers. A fraction is a comparison of two numbers. The numerator compared to the denominator. And that's going to have a fraction bar, okay? So in word form, you would have, for example, A to B. In ratio form, you would have A to B, and in fraction form, you have A to B. Notice I said that all the same way because you can read them all the same way. A to B, A to B, and A to B. So that word to is very important in ratio format, so we're going to be familiar with that. Okay, if I gave you a ratio 32 to 48, first of all, what form is that written in? Well, it's using the word to, so that's going to be your word form. And so whatever form I write it, I'm going to give you probably another form to say, all right, if it's whatever form it's in, write it in fraction form, or write it in ratio form, or write it in word form, okay? So this one's already in word form. I'll probably make you write it in fraction form, which means you would do 32 over 48. But if I told you to write it in ratio form, that would be 32 to 48. Again, I say them all the same way, but I write them a little differently. And I would tell you to do that. But if you're looking at fraction form, notice it's a fraction, right? It's a numerator compared to a denominator, but it's not simplified. So all your ratios have to be written in simplified form. So 32 over 48. What's the biggest number that fits into both of them? Most of you are thinking 8, and we'll see if that's it. So if I divide both numerator and denominator by 8, I would end up getting 4 over 6. Okay, so 4 over 6, and I check that. 4 times 8, 32. 6 times 8, 48. But is that the smallest number that can fit into both of them? And the answer to that is no, because 2 can fit into those. So you end up with 2 to 3. So what was the GCF? It wasn't 8, but it was actually 16. 16 goes into 32 twice, 16 goes into 48 three times. Even if you didn't know that, you can eventually get to that part at the end right there. Okay, so write your answers in simplest form. That's what you're going to be doing for a lot of problems, but they're going to give them to you in a little bit, a little more complicated, not too bad, but here's the type of problem you're going to get. Okay, here's the example. Write each in fractional form in simplest terms, okay? So here they're going to give us Chapter 10 test grades, okay? These are not ours, but you had 6 A's, 8 B's, 10 C's, 3 D's, and they do with the apostrophe. I'm not sure if it has it, but we'll trust them on that. And 5 F's. Oh, that's awful. 5 F's. Okay, so this was Chapter 10's test, and this is what you had for those grades. And we're going to look at a problem here that says, all right, give me the fractional form in simplest terms of A's to D's. So I look at the A's. I had 6, and I had 3 D's. That's 3. Okay, so A's to D's. This is a fractional form, but it's not in simplest terms. So I'm going to actually write it. If I'm talking about ratios, we tend to leave it even in unsimplified form. Or sorry, I shouldn't say that. Wow, I'm losing the word. Improper form, 2/1. So that's going to be your answer. That's simplest terms, and that's the ratio of A's to D's, so 2:1. So for every 2 A's, you had a D, is basically what it's saying there. The next problem, it does get trickier, but this one's asking me for the ratio of D's and F's to A's, B's, and C's. Okay, so that's a complicated statement, but it says here again, D's and F's to A's, B's, and C's. Now, what's that key word in that problem that we talked about with ratios? The word to. So I'm going to read it one more time, see if you pick it out. D's and F's to A's, B's, and C's. Okay, so that 2 right there. So D's and F's, that would equal a total of 8 to A's, B's, and C's. So 6 plus 8, 14, plus 10, 24. So that's D's and F's to A's, B's, and C's. That's the ratio between those two. And we realize that, wait, that's not simplified form. So what number goes into 8 and 24? 8. 8 goes into 8 once. 8 goes into 24 3 times. So D's and F's to A's, B's, and C's are 1 to 3. That means for every D and F, there was, or D or F, I almost should say, there were 3 A's, B's, or C's. So much more A's, B's, and C's than D's and F's in that class, which is good. And then the last problem for this type of example, they're going to ask A's to all other grades. A's to all other grades. So there were 6 A's, and then to all other grades. So 8 plus 10, 18, 21, 26. So there were 6 A's, and then all others was 26. So we look at it, what can go into both? 2 goes into that 3 times, 2 goes into that 13. So for every 3 A's, there were 13 other grades. So see how you can compare those? You could turn those into percents, and that'll help you to get kind of a, because we like dealing with percents, and we'll get to that later in this chapter. But fractional form, again, you're comparing 2 numbers. In this case, A's to all other grades. Okay, so that's what you're going to be doing part of the way for these problems here. You'll deal with marbles, and you'll deal with, I think, cars for these examples. All right, the second type of problem you're going to be doing is what we call a unit rate. So I'm going to write the definition. Unit rate. Okay, it is a ratio with 2 units So we're dealing with units now. And here I guess you can see where I call it unit rate, but that's actually a little bit more than just 2 units. A ratio with 2 units, and the denominator is 1. That's where you get the word unit rate. Unit means 1, unity, 1. Okay, so a unit rate has a denominator of 1. So you're going to be comparing two things like miles per gallon. And we use unit rates all the time, by the way, miles per gallon, miles per hour, feet per second, meters per second in science. We like dealing with a denominator of 1 because we're just like you did in the other problem. I think it was 2 A's to 1 D. So that makes sense. Every 2 A's has 1 D in that classroom. That's very easy to understand. So we like having a denominator of 1, but a unit rate has 2 numbers, just like any other ratio, with 2 separate units: miles, gallons, meters, seconds, kilometers, hours. So you have different unit rates. So here's an example of what you're doing for a unit rate problem. Okay, they're going to give you 256 miles, and I'll abbreviate here, to 8 gallons of gas. To 8 gallons of gas. Okay, and I'll just abbreviate 8 gallons. Okay, that is a ratio. It is a rate because it has 2 separate units, but it is not a unit rate. So I'm going to ask you on these to write it. You typically want to write it in fraction form, so we'll do that. So 256 miles, over 8 gallons. Okay, it is a ratio, comparison of 2 numbers. It is a rate. They have 2 separate rates, but the denominator is not equal to 1. Simple shortcut on this problem is just to divide 256 divided by 8. You just divide the numerator by the denominator. That's all you have to do on these problems. So here I do 256 divided by 8. So 8 goes into 25 3 times. 24, 1, 6. 8 goes into 16 twice. So my final answer is going to be 32 miles over 1 gallon. And we usually say that 32 miles per gallon. So 32 miles per gallon and 256 miles to 8 gallons are the same thing. They're the same ratio. But this one's a lot easier to understand, to compare, to describe. So we like unit rates. Okay, and then the last one for you golfers out there, which I am not a golfer. I've actually talked to more people about golf during this break, neighbors, and telling me they like golfing, and I'm like, I'm just not good at golfing, and I probably never will be. But here's a problem, and maybe you can tell me if this is good or not, because I don't know. 63 strokes for 18 holes. For 18 holes. Okay, 63 strokes to 18 holes. I think that's okay. I mean, I don't know. I hit that. Let's say that. That's what I got. So tell me if I was good or not. Okay, so I have 63 strokes over 18 holes. It's a ratio. It's a rate, but it is not a unit rate. So I'm going to divide these two out. The reason I can do that, by the way, guys, because I gave you the shortcut, but I can divide both of these by 18 because what am I actually dividing by if I divide both by 18? By 1. So I'm allowed to do that. So I'll do over here where there's no glare. 63 divided by 18. So 18 goes to 63. I'm guessing 3 times 54. I'm going to make sure. 18 times 3, 24, 54. Okay. So not more than that. 54. And that's going to get me 9. Then I'm going to have to bring a decimal out. 18 goes into 90. Let's see. 4 times, 5 times. 18 times 5. So 40. Oh, thankfully. Yes. 3.5. So my final answer is going to be 3.5 strokes. Probably should spell that right. Strokes per one hole. I'm guessing that's, I think that's good if it's a par 3 course, right? I know that much, I think. But I don't know. That's what I scored my last time playing, right? Okay, so unit rates had to have a denominator of 1, so you'll do some of those problems. Don't forget the units, and don't forget you're just basically dividing those two numbers together. And if you're dealing with money, you can round to the nearest hundredth. Anything else can round to the nearest tenth. Okay, so money, you always round to the nearest cent, and then everything else to the nearest tenth. All right, guys, I'll see you later. I hope you do well. Oh, your homework is numbers 2 through 18 even. 2 through 18 even before I go. And that's going to be found on pages 277, 278. And don't forget, we'll finish up this lesson tomorrow with unit conversions, and hopefully you'll be able to do it. So again, numbers 2 through 18 even, and then pages 277, 278. Okay, take care, guys. Bye.